Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Largest positive integer that exists with its negative. So basically we have an array of numbers that does not have any zeros, and we want to find the largest positive integer k such that the also negative minus k exist in the array. So both need to exist in the array, and we want to return the positive integer k. And if we can't find it, we want to return -1. Okay, so pretty straightforward to do. The easiest thing we can think about is, like, for example, with this one, we can first sort it, right? Sort the array so that we can have, we are guaranteed to have the negative ones before the positive ones. So for example, if we sort this one, we would have -3, -1, 2, and 3, right? And then if we do that, we can keep track of the ones we've seen, so that when we when we are at the positive number, we can check if we had seen before a negative number, because since this is sorted, the negative number would be before the positive one. Okay, so that means here we'll go -3, so I'll add -3, go here, add -1, and then when we have a positive number, so when, let's call these numbers the number a, so if it's positive, then we can check if minus a is in seen, because if it is, that means both are in the array. And so here when we check 2, we check for -2, it's not in the seen set, and so we advance, we check for 3, it's positive, we check if -3 is in the seen array, it is, and so so far our best one is 3, right? We need to since the problem says if we can't find it, we return -1, we can just initialize our best value to -1, and then if we find any candidate that has this property, we can set it here. Okay, and since we are looking for the largest positive one, whatever one we find at the end, that's going to be the largest one, because the array is sorted, right? So that's pretty straightforward. So first, let's just call this a, and let's have our seed set, and let's have a best value initially that is at -1, and let's have let's sort the array. And what we can do here is just go through the array, and if the value is positive and the -1 isn't seen, then we know this is a candidate. But also, if for each element we need to add it to the array so that we add the negative numbers. And so here, if that's the case, that means this is a good candidate. So let's just see if it's the max. If it's the max, we set it. Okay, and then at the end we just return best. Now if we didn't find any such number, then best will stay at -1, which is what we want. Okay, so that's pretty much it. We can just run this, except looks like I need this to be a set. Yeah, so just like that, can run this, we can submit, and it got accepted. Okay, now one other thing, so in terms of time complexity, this is O of n log n, right? For the sorting, this is O of n. So overall, since this is higher, it's going to be O of n log n time. And in terms of space, we are using this set, which is O of n space, right? So can we do better? Well, we don't actually need sorting if you think about it. What we can do is just have a set for all the elements. Let's call it just S here, or call it values set. And now we can just go through the arrays, and if we just find it, we just check the max. We don't need it sorted, because we don't need a guarantee that that the negative elements appear first, because we put all the elements in the set already. Okay, so if we find a number that is positive and we find that its -1 is in the set, then that qualifies, and so we just check if it's the best one so far. And so that's a little bit simpler. This needs to be value set. Okay, that gets accepted. Now in terms of time complexity, this is O of n, because we are only doing this one and this value set to convert it to a set. So it's O of n time, and still O of n space, but at least it's a better time complexity. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.